The world of data has become complex and fragmented. Estuary is a startup that is taming that complexity by making it easier to create real-time data pipelines. In this episode, we speak with Johnny Graettinger, the co-founder of Estuary, about data fragmentation, DataOps, data pipelines, and their product, Flow. Johnny Graettinger is a successful entrepreneur and technology leader in the world of DataOps. He was the co-founder and CTO of Arbor, a company that created a marketplace for people-based data, which was acquired by LiveRamp in 2016. He was the creator of Gazette, an open-source project which is used as infrastructure for building streaming data platforms. And most relevant for our interview, he is the co-founder of Estuary, a startup that is making the development of real-time data pipelines easier than ever before. I hope you enjoy my interview with Johnny. So Johnny, you're the co-founder of Estuary, but I'm wondering if you can take us back to your early career, how you first got into computing, and then how your career led you to Estuary.
Yeah. It's been a bit of a journey. I've been into computing for a long time. It's kind of all I've ever really wanted to do. But what I kind of had focused on, I went through the phase of wanting to be a video game developer, which was very short-lived. Though I did a bunch of graphics work at school. I got into natural language processing sort of in the late stages of college. And this was, of course, well before deep learning or any of the new advances in sort of AI that have come out since. I was working with a lot of data even then, and this is back in like 2006. So it was very much sort of a big data problem to sort of train these models for machines understanding speech and language. I ended up kind of following my girlfriend, now wife, to Philadelphia because she was starting grad school, and I needed to find a job. And at the time, pickings were a little bit slim in Philly for kind of interesting engineering work. That's changed a lot, of course, but at the time, there wasn't too much, but my wife found me this kind of interesting job with a startup called Invite Media. That hey, they had some interesting data problems. It looked pretty fun. So I kind of just on a whim made the leap into that space, which is like that company was in the what's now known as the advertising technology space. So it really like that transition was by accident. And whatever your feelings may be around sort of the advertising industry in general, from an engineering perspective, it has like fascinating data problems, just in terms of the volume of data, the speed in which you need to process it, and that kind of thing. So, as I said, I joined that startup, Invite Media, which ended up being bought by Google about a little over a year later, and stayed on through that transition and eventually became the technical lead for that product. And we also migrated it over to like this, to DoubleClick Bid Manager, which is like this big advertising product inside of Google. From there, it was kind of a natural leap to then sort of try striking out on our own. I'd been working with my co-founder, Dave, very closely for a number of years by that point. We kind of met and had worked together through Invite Media and through the acquisition with Google. So it kind of made sense to try and launch a company on our own, see if we could do it. So we made that leap in 2014, and just because we were so familiar with the advertising space, it made sense to sort of start that company in that space as well. And yeah, it's kind of been a continuous journey all along the way. We started that a company called Arbor in 2014, which was sort of like, it was advertising adjacent. It wasn't directly in like showing people ads or anything, but it had very large scale data problems. There were lots and lots of like points of information that were coming at us very rapidly. And it really mattered from a business perspective that we were able to like take all this data in very quickly, assemble it into sort of a more comprehensive understanding of what all these data points meant when stitched together, and then be able to act on that. And that kind of led towards building some of the initial technologies that we're now building upon as Estuary.
Can you give us the elevator pitch of Estuary? And keep in mind that a lot of our audience is not familiar with data ops or data pipelines.
Yeah, the elevator pitch it's like the one sentence is basically like your data kind of where you want it to be. And the sort of slightly unpacked version of that is that modern businesses today, like we don't have like one or a couple of data systems. We have like a ton of data systems that we're all working with. And by data system, I mean like your database, but I also mean like software as a service companies that have data on your behalf, where you're like paying someone else to do something for you, but they have data about your business, or caches that we're using to sort of help host and front our APIs, or providing scalability for our database, or cloud storage where we're putting a bunch of data, or our analytics warehouses where we're kind of working with data, or services or systems that we're using to power like search within our product. So I could go on and on. There are lots of examples of sort of interesting data systems that we kind of, as modern enterprises are piecing together to build sort of more interesting infrastructures and capabilities in the applications that we build. So the challenge then is that you've got this like kind of Cambrian explosion of like interesting data systems and tools to use for building businesses, building like your understandings of what's happening within your organization. But you have a synchronization problem where, as a discipline, we as engineers are spending like an inordinate amount of time sort of building pipelines and processes to like pick up data from one place and move it into another. So the core of Estuary is like, can we essentially sort of take a description of all of your data systems, all of your sort of collections of data, a new vogue way of calling them is sort of data products, and take that description of all of this stuff and just sort of make it continuously synchronized so that all of the systems you have, like your data sets, are synchronized across all of them, and yet they're talking about the same data in each of these systems.
So, Johnny, I'm hoping that we can define some high-level terms for our listeners. Can we start with the term data ops? What is data ops?
Yeah, and I think if you polled 5 people, you'd probably get 5 different answers for this, but I'll give you my definition. Data ops it's fundamentally the concern of data management and movement within the organization. It's making sure that the data that's necessary for various business functions is kind of where it needs to be, that the health of that data is ensured, that you're sort of verifying the quality of that data over time, the actual processes that are moving that data and having it in the right place. So it's fundamentally sort of like the constellation of concerns around how do you make sure that the data that the organization needs is where it's supposed to be, on time and with appropriate quality.
Okay, great. And another term that you use on your website is a data pipeline. What's a data pipeline?
Yeah, a data pipeline is pipeline for lack of a better term, but essentially a flow of data from one place into another, potentially with transformations being applied along the way. So I might have sort of a more raw data product where I've got these rather granular and verbose like logs that are coming in from a serving operation I'm doing, and I want to kind of refine that data over time by sort of enriching it with some additional information, cleaning up and normalizing the presentation of that data, and so on, potentially joining it with other data sets as well, or maybe doing some aggregation. And I'm transforming that data product along the way, and then finally putting it somewhere. So that's at a high level what a data pipeline is. Of course, they're not sort of direct end-to-end pipes. You can really kind of think of it as a graph, often like a directed acyclic graph of data flows, where we're taking all of these flows of data from sources of various sources and transforming them and putting them somewhere.
Great. Okay. Now I think you can tell us about your product, Flow. How does Flow work? What does it do? How does it relate to the terms that we've already talked about?
Yeah. So there are 3 fundamental legs to what Flow does. First of all, it enables you to capture data from a slew of different data sources that you might have. You capture data through what we call connectors, which are kind of like a Docker containerized plugin that wraps up all the details of working with some specific data system. So we have connectors for working, capturing from a Postgres database, for example, or capturing from HubSpot, various SaaS services. So these connectors are kind of like pluggable components that represent talking to some particular data system or API that you have. So Flow is driving these connectors to capture your data into essentially a real-time data lake that lives in your cloud storage. So this means all of the historical content that's been captured is available as just regular files in your cloud storage bucket, but it's also very, very low latency, like millisecond latency. So as data is captured, anything that might care about that particular data set being captured is able to react to it and respond to it very, very quickly. The other two kind of legs of what Flow does are derivations, which are how you kind of transform and build new kinds of data sets by enriching or mapping or transforming others. And then materialization, which is taking a collection of data and pushing it into a data system that you have, like a database, such that it's always kind of up to sync. It's a continuously materialized view over the content of that data set.
How is Flow able to connect to existing data sources? Do you have to write custom wrappers for each kind of data source?
Yeah, this is a kind of an interesting trend within the broader ecosystem. We're not the first company to focus on this problem of like moving data from one place to another. Another really, a large company in this space is Fivetran. It focuses more on sort of periodically like copying data sets from one place into another. One of the challenges of building a business like that is that there are so many places that you can potentially want to pull data from or push data to. I think more than any one company can really stay on top of, where you're writing each of those as like a new product feature. So an interesting trend in the broader ecosystem is kind of the rise of open source connectors, where companies, Estuary, other companies as well, are building connectors that are built to a common specification that are then kind of interoperable. We write many of the connectors. We're focused in particular on connectors for sort of high scale technical systems like database change data capture and things like that. But there are also, there's a kind of a stable of open source connectors that other folks have written that are more focused on sort of capturing from various SaaS APIs and other sources of data as well. So what we're trying to build sort of as a more of a community is a suite of connectors that are more interoperable than what we've seen in the past with data products that are tackling this kind of goal.
Yeah, and I'm hoping we can dig more into that, how Flow is different from the products that came before. You started to touch on it, but what's kind of the value here over the existing products in this marketplace?
Yeah, I'll highlight just one area to talk about. Flow is entirely incremental in terms of how it operates. And what that means is that rather than like taking all of the data that's in a database and periodically copying it into like your analytics warehouse, like Snowflake, what Flow is doing is it's looking just at the changes that are happening in the sources of data and the destinations of data. So it's really just kind of finding exactly what changed along this data flow and propagating the effects of the changes to these various data sets downstream, ultimately into that materialized view. And to give it like a example of why that's really important, I gave a presentation last week where I was showing off sort of a large scale like benchmark of Postgres, where this Postgres database was being hammered with a ton of data. It was a pretty beefy Postgres database. It was like 2 terabytes. And what I was showing off was essentially capturing the changes to that database and materializing like views of this data into a Google spreadsheet that was updating once per second. And like to put that in perspective, if Flow was able to keep those kind of, they were basically kind of reporting queries. We were looking at like some events and kind of aggregating like how many of these particular things are we seeing each day, that kind of query. These are queries you could easily ask that Postgres database to answer. But the major difference is that if you ask that same query of that Postgres database, it's going to take a minute. Like it's going to take a little bit to walk that entire table and perform that aggregation and spit out the answer. And what Flow is able to do, because it's just looking at the changes that are happening to these data sets, is it's able to figure out the effects of those changes much more quickly than the Postgres database itself could.
So it's much more efficient.
Yes. Yeah, it's efficient in like sort of the movement of data, like literally how much data do I need to send over the network? And it's also efficient in terms of the CPU cost of computing these updates.
Can you walk us through some hypothetical scenarios where a company may use Flow? And of course, I know you can't go into the specifics of what your current clients are doing, but just from a broad hypothetical point of view, what would be a potential scenario where someone may employ Flow? And maybe you could talk a little bit about what kind of data sources they may be using and how they want to transform the data and how they ultimately want to synchronize the data. What do they want to synchronize it to?
It's kind of a multi-layered answer, just because as a young startup, it's our job to sort of bring people along in terms of the broader vision for how we think they should use Flow over time. And we're sort of entering a market at this stage where people have not really heard of Estuary so much, but they may be somewhat familiar with this space. So it behooves us as a company to present a product that's familiar to what people are already using. And that's kind of, this is often called a go-to-market, and that's kind of how we think about it. So the initial, like, what are we thinking people are using this for question, it looks similar to other products in the space, just because we want it to be familiar to people who may have used those kinds of products. So fundamentally, I have a source of data over here that might be a database, or it might be a SaaS API, or a cloud storage bucket where a bunch of files are being dumped, whatever. And I've got some place where I want that data to be, which is most typically like an analytics warehouse or another database or something like that. And what we enable first and foremost, sort of a bread and butter use case, is just setting up that data flow in a way where it's just always running and always in sync, where that target system is just always up to date with that source system. And that's sort of like where people tend to start with Flow. So other kind of fun examples that are like in this more simplistic, like I've got one source of data and one destination of data. It's like I have a Postgres database that has a bunch of product metadata in it, and I want to integrate a search service that's going to stay up to date and be indexed with like the current state of my product information that's in my database. So that's something that Flow can help power. Or I've got like a cache that I want to put in front of my database just to reduce some of the load on that database from my serving API. So those are all sort of simpler examples of more sort of point to point, taking a source of data and putting it into another alternative data system. Where you go from there, though, is that what's neat about Flow is that these collections of data, once you've captured data from a database, for example, you are able to use that data over and over again. So without going back to the database, once I've set up a data flow that's capturing data that I care about from that database, I can then use that captured collection of data for multiple different use cases. I can flow it, I can plug it in to sort of support a caching tier in front of my API service. And I can also flow it into my analytics warehouse or into another database. And I'm able to sort of repeatedly use it over and over again for different purposes. And that's what we're really excited to bring to the community in terms of how they can think about and use Flow longer term, is just sort of enabling these much more complex sort of data transformations and constellations of different data systems that they're bringing to bear. So, and then in terms of transformations, there are all kinds of, I'm actually pretty excited to see what people come up with, because I don't think I'm personally imaginative enough to know what use cases people are going to, find value in this for. But some commonalities in the types of transformations are being able to report over what's happening within the business. Like for example, imagine like an e-commerce company on Black Friday, like the most important sales day of the year. They have a bunch of sort of sales and orders and whatnot, and they want to understand what's happening within the business, and they want a really up to date understanding, because this is like the most important sales day of the year. If there's a problem, we want to know about it as soon as possible so that we can do something about it. An example of transformation that's really valuable to them is just being able to sort of create a roll up essentially a reporting query that's letting them know, for each of my product lines, for example, how are they selling over the day, or how are these different campaigns that I have for advertising my products performing, and what should I do about that? So those are the types of questions that you can start to answer with transformations.
That sounds really powerful, and I imagine that right now solving those kind of problems involves a lot of custom code that Flow can replace. I'm wondering, who is it at a typical software development organization that would be responsible for integrating a product like Flow? Is it going to be software engineers? Is it going to be database administrators? All of the above? And how much work is it to integrate Flow?
Yeah, it's typically going to be sort of data engineers, though there can be a variety of stakeholders within the organization. I mean, increasingly, kind of everyone within an organization cares about these data systems. They're so fundamental to the business and understanding what's happening within the business that there can be a good number of stakeholders. But what we're getting to as a product is that users are able to essentially sort of come into our dashboard, come into our UI, pick the source of data that they have, and provide the configuration that's needed. If it's a database, like where is this database living, that kind of thing. And then the tool is essentially able to tell you, okay, here are the tables. These are the sources of data that are that exist within this system. What would you like to capture, essentially? So you can actually go and create a data flow where you're capturing data from one place and materializing it to another without writing any code at all, just purely through the UI. As you start to layer in more complex use cases where you're doing transformations and that kind of thing, that's when Flow is a low code environment, and that's when you're starting to write some source code. But if you're really talking about just moving data from one place to another, you can do that purely through a web browser.
That's great. I'm wondering if we can go even higher level now. What you've described is a world where data is very fragmented, and that's kind of the current world we live in. And that's why there's a need for a product like Flow. I'm wondering, thinking through your history in the industry, if you have some thoughts about how we got to a world with such fragmented data living in so many different sources. Was that just a natural outcome of the way that software engineering as an industry has evolved? Or is there something about the world of databases that kind of led it to be this way, and data sources more generally?
Yeah, that's a good question. And just to give a bit of history here, or history as I perceive it, at least. So roughly, maybe 10 years ago, people started to get pretty excited about sort of real time. There were use cases that really legitimately needed real-time data, where you're sort of building data systems that really want to know about things that have happened in other parts of the infrastructure really quickly. And a lot of companies kind of raced to adopt streaming infrastructure to serve some of those use cases. And I think a lot of companies kind of overdid it. The reality is that building streaming data systems is actually really, really hard. There are a lot of gnarly sort of problems that you don't necessarily see, lurking under the water, that you kind of you don't know about until you suddenly hit them. And then you're kind of dealing with production outages and that kind of thing. So I think a lot of companies kind of got a little bit burned out on building these types of systems. And there's almost been kind of a streaming winter, I would say, for the last 5 years or so. In the meantime, there's been the rise of this concept called the modern data stack, which is fundamentally about, if I had to describe the modern data stack in a nutshell, it's let's get all of our data, all of it, into one of these really large scale analytics warehouses like Snowflake or BigQuery, and let's do all of the transformation within that warehouse And then we can use tools like DBT to sort of have a principled way of expressing those transformations, and then have that be our one and only sort of data environment where we're working with that data. And that's been really attractive to a lot of companies because it's so easy. It basically essentially boils down to writing SQL for most of these transformations, and you have sort of one environment where all this data lives. And like, I have a bit of a pendulum metaphor where it's like we've gone from people being burned out on real-time streaming to being all in on the modern data stack. But the problem with the some of the pitfalls in the modern data stack are that, number one, it's kind of expensive. Fundamentally, the modern, it involves like doing a lot of copying and reprocessing of data over and over again. And two is that it's not great for sort of more operational use cases. It's great if I have an analysis that I'm okay running once a day or something like that. But if I have like data that I need to act on quickly, it's a bit more problematic to sort of get it out of that environment. We've over time, kind of a lot of companies have evolved these two-part approaches where they've got sort of like some streaming infrastructure that they're using for like really important main line of business tasks. And then they've got sort of like these big analytics warehouses where they're sort of dumping everything else. And then we've also had like a lot of investment and development of really interesting databases that are serving different kinds of needs, whether it's super fast query response, like loading your entire data set into GPU memory and processing it there, or allowing for sort of really kind of semi-structured search over your data. There are like a variety of interesting data products that have kind of come onto the scene that folks are using for different purposes. And then we also, of course, have the clouds who are all sort of competing with each other and all have interesting and different databases and data systems. So, most companies they've got like a foot in a lot of different places, essentially, in terms of the data systems they're using.
That makes total sense. I'm wondering if I can ask you about a totally tangential issue to our discussion, but I thought one that you might have some insight into, which is the rise of NoSQL databases over the past decade and a half. There's really been a lot of excitement about them. Do you feel that they've been oversold a little bit? And how do you see that movement evolving?
I actually think I'm going to tie that back into sort of the the narrative I just gave, because there is a lot to like about NoSQL, just in terms of if you're building an application that's like reacting to a user coming in and asking for something, and it's got to pull some data from some different places. It really is nice as the writer of that application to be able to ask an endpoint to like give me back, hey, can you give me this nice sort of denormalized like document that has all the stuff that I could possibly need? Can you just give that to me rather than me needing to go fetch out from like a bunch of different normalized tables or places where that data lives? So I'll actually tie together sort of NoSQL databases and also with technologies like GraphQL as ways of sort of fronting what might in actuality be like a more traditional database with an API that allows for people to really flexibly ask for like data in the shapes that they want it. So I don't think it's going away at all. And there are really nice reasons for wanting to be able to sort of read and write documents that kind of capture like a bunch of data together in sort of this denormalized payload of like everything that I know about some particular user or event or what have you. But I think what is probably beneficial both for like the NoSQL systems is like they essentially have the same kind of problem of like, all right, I've got this NoSQL database. I want to integrate it with other data systems I might have that, are sort of tabular or SQL in nature. How do I do that efficiently? And that kind of speaks to like this pervasive engineering challenge of needing to write sort of applications that pick up data from one place and move it into another.
That makes a lot of sense. I'm wondering if there's a rule of thumb for when an organization might need a product like Flow. What kind of problems are they running into when Flow becomes appropriate?
As soon as you're moving beyond, like if you're running your entire database or your entire business rather on a single database, then Flow is not necessarily going to help you. As soon as you're looking at integrating, for example, you have a partner company who's delivering data to you in cloud store, via a cloud storage location where they're dropping files, or you have a new analytics warehouse that your business intelligence team wants to bring in, or as soon as you're starting to assemble multiple different data systems that are all holding essentially your data just in various shapes or forms of it, then a tool like Flow starts to become more important. It especially becomes important if you want to build places where you have data that are kept up to date. So I have, for example, you're building a sort of a user store that tells you what you know about your various users. That needs to stay up to date with sort of the interactions that you're having with those users. Or, to go back to an earlier example, you want to integrate, a tool that's going to power search for your site. And you want to be able to feed it all of your product data and have it stay up to date as that product data changes. Essentially, when you're combining multiple data systems that you're using within your company, and you care about having them be in sync with each other, that's when a tool like Flow starts to become more useful for you.
That makes a lot of sense. Well, Johnny, thanks so much for being with us today. I think we've learned a lot about data pipelines, about the whole DataOps industry, about Flow, about Estuary. How can our listeners follow you on social media or follow Estuary on social media? And of course, we'll put links to Estuary in the show notes.
You can find us on Twitter. A good place to honestly for engineers to reach out is either through Slack, which we have kind of linked from our site. We have a public Slack group that people can join, or GitHub. We actually do all of our development in the open. So if you go to github.com/estuary, that's where we develop the entire product essentially. So those are two places to sort of keep tabs on what's happening and reach out and what I would recommend.
Great. And I understand you're hiring. Do you want to give a little plug for positions that you're hiring for and what kind of candidates you're looking for?
Yeah. We are. We have a lot of work in front of us, just in terms of building out new and interesting ways of powering transformations, new types of connectors to different systems. And improving the runtime and our UI dashboard as well. So we're hiring in a bunch of different roles. One top of mind one is a developer evangelist role, which is fundamentally about helping us tell stories backed by sort of Git repos of how Flow can be used to solve problems. And another is, we're just always looking for good backend engineers as well to help us build and improve the core functions of the product.
Well, Johnny, thanks so much for being with us today.
Great. Thank you for having me.
Okay, thanks for listening to us this week. Rebecca, how can people get in touch with us?
We're at Kopec Explains, KOPECEXPLAINS.
On Twitter. Thanks for listening, and we'll see you in 2 weeks.
Bye.